let's look at another example of using these thick lens formula. And in this particular problem, I'll just read it here. We have a concentric lens in air that has radii of minus 5 centimeters and minus 8 centimeters respectively. And it's made from glass of an index of refraction of 1.5. And we're asked to locate the principal points F1, the primary and secondary focal points, and then the primary and secondary principal planes H1 and H2, and then draw the locations of everything on a figure. You have to know what concentric means, and concentric means having the same center. So that one isn't in your vocabulary, we'll put it in there. So we have a lens that looks like this. They have the same center, so C1 and C2. They're both negative surfaces, and so our lens with a negative surface is concave, and likewise the second surface is concave. They both have the same center. This one's 8 centimeters, this one's 5 centimeters, and so the thickness of the lens at the center is going to be 8 out to here and minus 5 or 3 centimeters. Again, thickness is always positive in this formulation. So we have a 3 centimeter thick lens, and from its shape you might suspect that it's going to be a diverging lens, and we'll see if that's the case or not. As usual, we simply sort of mindlessly come in and compute P1 and P2 first thing up after we've done a little bit of interpretation there. It's in air, so and the index of refraction is 1.5, so 1.5 minus the index of refraction on the front of the lens, which is 1, and R1 we're given as minus 5 centimeters, and so we get P1 as this minus 0.1 reciprocal centimeters, and P2 likewise is N2 minus N1 over R2. In this case, it's air on the backside as well, so we've got 1 minus 1.5 over minus 8, and that gives us a positive 0.0625 for P2. And once we have those, then we can use this formula here. Maybe go down a little further. And formula here to compute F2. Again, N2 is 1. Substitute in P1 and P2 and the thickness. Do the computation. I get 1 over F2 is minus 0.025. And then make sure that you don't stop there. You have to take the reciprocal of it to get F2. So F2, it turns out in this case, is 40 centimeters. From that, we can get the script F2, the back focal length, and that's just F2, the focal length minus P1 over N. We plug in thickness T, P1 we calculate as minus 0.1 and divided by N, and we get F2 as minus 48. We're in air, so we don't really have to use a formula specifically to get the principal focal length, F1. We just have to remember that it's equal to minus F2. And since F2 was minus 40, a minus gives it as positive 40. And once we have it, then we can likewise compute the front focal length, FFL. And that's just with this F1, 40 centimeters. This is P2, so we use it. T is 3. And we get 35 centimeters. From those, we can compute H1 and H2. Remember, H2, the back one is the BFL, back focal length, minus the focal length F2. And F2 was minus 48. And F2 was minus 40, minus a minus gives us a minus 8. And H1 is F1 minus F1, script F1 minus F1, and that's 35 centimeters minus the focal length, which, if you remember, was 40 from earlier. Well, right here was 40. And so 35 minus 40 gives us minus 5 centimeters. Now we have to come in and draw all of this, so that's maybe the more difficult thing. I usually, well, it varies, but what I usually do is locate the location of the principal plane with the H1 and H2. H2 is minus 8. And remember, the secondary principal plane is measured from the back vertex. So I go H2, I go negative to the left 8 centimeters. And since this was a circle or a sphere of radius 8, that puts us right back on the center. So there's our principal plane. H1 is similar, except it's measured from the front focal point. Remember, everything with ones on it, that front distance to the principal plane. Again, it's negative, and so that means I go to the left. And again, this was a 5 centimeter radius spherical surface, and that puts us right back on top of the center again. So this is kind of an interesting case in which both of the principal planes are at the same point. So H1 and H2, capital H1 and H2 are the same as C1 and C2. Once I've located the principal planes, then I can locate the focal points, or I could do it as well from the script F1s. Let's do the script F1 first, or script F2. Script F2, I can pull it from here as minus 48, and so it's negative, so I'm going to go from the vertex to the focal point, and I have to go minus 48. It's this total distance here. So F2 is actually in front of the lens. F1 was 35. I measure it from here. It's positive, script F1 is, and that's the distance from the front vertex to the primary focal point. And again, that's this distance here. So there's F1 that's actually on the back side of this. So that's like a diverging lens, actually. There's other ways to locate all of these, but that's by virtue of, once I know the location of the principal plane, then I can locate, well, for instance, F2. F2 is measured from H2, and F2 was 40 centimeters negative, and so I go from here to locate F2, which is the minus 40, so you can also get it that way. Pretty obviously, this distance from here to here is 8 centimeters, and this is minus 40. Things aren't drawn to scale here, obviously. And so I get the same relationship, 8 centimeters to here, and then 40 centimeters on to get a minus 48 for F2. So either way, you're able to locate that focal point. Likewise, for the primary focal point, capital F1, I could once I know where H1 is, I can use that reference plane, and knowing the focal length F1 is positive 40. And so from here to here is 40 centimeters, and that would locate the same instance of it. Okay. So either way, you get a diagram that looks something like this, and that is really sort of as complicated as these kinds of problems get. You can have different curvature surfaces, and one could be flat, or one could be convex, and one could be concave. So it's just mix and matching and doing that same procedure over and over again. I don't I don't think your textbook does this in quite the same way, so I'll put into the reading assignment here the section from your textbook on thick lenses, and you can use whichever method you're most comfortable with, either the one I present in class or the one that you can read